Hello everyone, welcome back. If you're new to the channel, make sure you subscribe to this channel. In this particular video, I'm going to be going over how to write the molecular, complete ionic, and net ionic equations for acid-base reactions. And in this particular video, we're going to focus on ammonium carbonate reacting with hydrochloric acid to yield a clear bubbly solution. So let's get into this. So the first thing you want to notice is that we're given names of the substances instead of formulas. So we're going to need to know how to go from the name to the formula. And if you're struggling with that, or if you're a little bit rusty, then make sure you go to my video on naming ionic compounds where I go over that. I'll link that in the description below. I also have a video on naming naming acids. So if you're weak on that and you need a refresher, then please see that video. I'll link that in the description as well. And so let's get into this. So here we have ammonium carbonate. That is an ionic substance. So we need to identify what the ions are. And the name tells you what the ions are, because when you name an ionic substance, you take the names of the ions, you put it together. That's the name of your ionic substance. So now we're just going to go backwards. So we have ammonium and we have the carbonate. Both of these are polyatomic ions. So I'm sure your teacher gave you a list of polyatomic ions to memorize. You're going to need to know those. I have a video that goes over polyatomic ions. I'll link that as well as in the description. So if you want to go over that video, in that video, I give you patterns and tricks to learn how to easily memorize those. Okay, so here is ammonium. Ammonium is NH4 plus, and carbonate is CO3 2 minus. So these are the polyatomic ions. So now in order to create the formula, we just need to make sure we're balancing the charge. So here we have the plus charge and the 2 minus charge. So that means we need 2 ammonium ions to balance the charge on the carbonate ion. So when we do that, we're going to need to use parentheses. So we have NH4 in parentheses, and we're going to need 2 of those. And we have CO3. So that's the formula for ammonium carbonate. So we're going to add to that hydrochloric acid. So right away, when you look at the name, there's 2 kinds of acids. There's the binary acid, and then there's the oxy acid. And the oxy acids and the binary acids are named differently. And so right away, if you see hydro, if the name of your acid begins with hydro, that's a giveaway that this is a binary acid. So you're not going to have the polyatomic ions with the oxygens like nitrate or phosphate or sulfate or anything like that. So this means that you have a binary acid. And what that means is you have 2 elements typically, and one of those elements has to be hydrogen because it's an acid. So hydro refers to hydrogen, and then the rest of it gives you the other element. So here we have chloric, so that's referring to chlorine. So this is going to be hydrogen and chlorine together. So we write that as HCl. And you can see how many H's I have in my formula. Chlorine typically forms a -1 ion. So the H plus ion, you only need one of those to balance. So you can think of it that way too. All right, so now I have my 2 reactants. And so let's form the products. How are we going to form the products? So one of the things you want to notice is you have an ionic substance here, and you have an acid, and this is a strong acid. So acids are not ionic substances, they're molecular substances, but they will ionize into ions when placed in water. And so here we have a strong acid. And so we need to keep in mind what a strong acid is versus what a weak acid is. And a strong acid is an acid that will dissociate, or I should say ionize, completely in water. So none of this is going to be left off, or very, very little of HCl is going to be left. All of it, or pretty much all of it, is going to be ionized into H plus and Cl minus. So a weak acid, if this was a weak acid, most of it would stay together in molecular form. So this is going to fall apart, but we're going to put aqueous. Either way, we would put aqueous, but in this case, we got to keep in mind that this is going to ionize completely in water. And this is aqueous because if we look at our rules, we have a carbonate and we have ammonium. It says here that carbonate, where's the carbonate? It says that all salts that contain carbonate are insoluble unless you have an exception. And one of those exceptions is ammonium. So if you have ammonium with your carbonate, this is soluble. Otherwise, it would be insoluble. The other exception is your 1A metals. So the group 1A metals would also be an exception. So this is going to be aqueous. So we got aqueous, aqueous. And so we're going to treat, because this is, we're going to treat this like an ionic substance because it ionizes in water. And we have an ionic substance here. Whenever you have two ionic substances or pseudo-ionic substances together as reactants, that's a dead giveaway that you've got a double displacement reaction. And what that means is that what we can do is put the inner ions together, and then we're going to put the outer ions together to form our products. So all we need to do is put the ions together and balance the charge to write the formula. So here, NH4, the ammonium ion, has a +1 charge. Chloride ion has a -1 charge, so it's the same charge. So we can put 1 to 1 together. So that's going to be NH4Cl, ammonium chloride. And then we could do the same thing with your hydrogen and your carbonate. Hydrogen has a +1 charge, carbonate has a 2- charge. So we're going to need two hydrogens to balance the -2 charge. So that's going to be plus H2, CO3. So there's our products. So now all we need to do is balance the equation and write the states of matter. So here we have two ammonium ions. And here we only have one ammonium ion. So we're going to have to put a 2 here, 2 coefficient. Here we have one carbonate, and we have one carbonate there. That's good. Here we have one hydrogen, but here we have two hydrogens. So we're going to need to put a 2 there. And now we have two chloride ions and we have two chloride ions. So now we have our balanced equation. So what about our states of matter? So we got the states of matter of these. We're going to have to get the states of matter for these. So ammonium chloride. So we got to look at our rules for solubility. And so when we look at chlorides, it says all chlorides, bromides, and iodides are soluble, except when you have silver or when you have lead 2 ion or your mercury 1 ion. Here we have ammonium, so that's not one of the exceptions. So this is going to be aqueous. And here we have H2CO3. We should recognize that as carbonic acid. And carbonic acid is a weak acid. So that's going to be aqueous. Okay, so that's going to be aqueous. And so there's something special we need to keep in mind here in just a moment. So now we have our balance equation. We have the states of matter. Now that is going to be our balanced molecular equation. So we got that. Now we need to write our ionic equations, our complete ionic equation, and then the net ionic equation. So when we're writing our complete ionic equation, we need to separate everything into ions. So what's going to happen here is this is going to be separated into ions. This ionic substance is separated into ions. This is a strong acid, so that's going to ionize into ions. So these can be written separately. This is also an ionic substance that's going to separate into ions. And then we have this, and we're going to get to this in a moment. So, well, why don't we talk about it now? So one of the things we need to recognize is, notice I have aqueous here on both sides, and I have aqueous here on both sides. Normally, you might recognize this and say, okay, this would be a no reaction because everything's aqueous, or this is a weak acid, so that might be the product and that'll stay together. But notice that it's saying it yields a clear bubbly, oops, that should be an L, bubbly solution. What does the bubbly mean in this case? Why is it bubbly? It's because there's a gas being formed, right? So whenever you have a reaction and it bubbles, a gas is being produced. That's an indication that you're forming a gas. But if we look here, there's no gas. There's no gas. Where's the gas coming from? The carbonic acid. Carbonic acid breaks down into carbon dioxide gas and water. So this is what is ultimately formed: water and CO2 gas. So the carbonic acid is actually one of the ingredients in soda or your soft drinks. That's what gives it its bubbly, tangy taste, along with um, uh, uh, phosphoric acid. They add a little bit of phosphoric acid in there. So basically, you're drinking acid. No joke. So really bad for your teeth for that reason. Also because of the sugar. But I digress. So here, you have to recognize this as a gas evolution reaction. So anytime you form a carbonate as a product, you're going to form carbon dioxide as a gas. So watch out for carbonate. So here you have a carbonate that's part of your carbonic acid, but that's going to break apart into carbon dioxide and water. So these would be the final products for that. So that's where the bubbling is coming from. And so now that we can write our complete ionic reaction here, so we're going to separate these into ions. So we have NH4 plus, and that's going to be aqueous. So again, notice that when I'm writing the ions separately, I am putting the charge in the aqueous. And also notice here that I have two ions here. I'm not going to write the subscript. That's not what I'm going to do, because this would indicate that somehow I have those bonded together, and they're not bonded together. So let me erase this and make it right. So here, since I have a 2 subscript indicating I have 2 ammonium ions, I'm going to rewrite that as a coefficient 2 with my NH4 plus, and that's aqueous. So I have my 2 subscript becomes a 2 coefficient. So your subscripts for the ions, the number of ions you have, become coefficients in your complete ionic reaction or equation. So then I have 1 carbonate, so I'm going to add that. So CO3 2 minus aqueous. I have 2 H's and I have 2 chloride ions, 2H plus and 2 chloride. This is going to ionize, so I got 2 H plus aqueous plus 2 Cl minus aqueous. So now I have my reactants separated into their ions, and now let's do the products. So here I have an ionic substance that's aqueous. That's going to go into ions. So I have a 2 there, so that 2 is going to apply to both ions. So I have 2 NH3, oops, that should be NH4. Oops, let me fix that. So NH4 plus aqueous plus 2 Cl minus aqueous, and then I have water and carbon dioxide gas. So plus H2O liquid plus CO2 gas. So there's my complete ionic equation. It's still balanced. So CIE, complete ionic equation. So now to find the net ionic equation, I need to identify your spectator ions and remove them from the equation. So how do we identify the spectator ions? Well, the way you do that is first, one way you do that is what created the products in your reaction, right? So anything that combined to form those products would be the players or the ones that are reacting. Those would be not the spectator ions. So that's one way to do it. But you'd have to go back to this to see what those ions were. It would be, it looks like it would be the carbonate and the H plus. Another way to do that is to look at both sides of your equation and see what stays the same. If there is no change from reactant to the product side, then that is a spectator ion. So for instance, here we have 2 ammonium ions, aqueous. Here we have 2 ammonium ions, aqueous, no change. That would be a spectator ion. And also we see that it's not part of this reaction here, this product here. The carbonate ion, CO3 2 minus aqueous. And notice that we don't have it over here. So there's a change there regarding this. So that is a player. That is not a spectator ion. That's part of the reaction. Same for the H2 plus. Here we have H plus aqueous, 2 of them, but we don't have any H plus here. So there's a change there. So that is also part of the reaction. 2 chloride ion aqueous over here, 2 chloride ion aqueous over there. So that is a spectator ion, no change. So we can remove that. Now everything else stays and we write our net ionic equation. So it's going to be CO3 2 minus aqueous plus 2H plus aqueous, and that's going to go to H2O liquid plus CO2 gas. And there you have your net ionic equation. And so you can see that these two are going to react to form water and carbon dioxide, and thus you have your clear bubbly solution. Because it's clear because all you have is water, right? Water is formed and that's clear, and then the CO2 is your bubbly part. So I hope this was helpful. I hope you enjoyed this video. If you like this video, if it helped you to learn in any way, please hit the like button and subscribe to my channel. Hit the notification button so you can be notified by any other videos I put out. And please put a comment in the comment section. Let me know what you think and if you have any questions. Thanks for joining me and have a great day.